This section, section 3, is all about geometric sequences. Geometric are when you multiply to get the next number. So whether you're multiplying by an integer, so like 2, 10, -5, okay, or you're multiplying by a fraction. So you're not really thinking like with arithmetic, you're always thinking adding, even if it's negative numbers. Geometric, you're always thinking multiply, even if it has to be fractions. So like instead of dividing by 2, you would think of that's multiplying by a half. Okay, this is your formula for your nth term. A1 times r to the n minus 1. A1 is still your first term, always your first term. N is how many terms you have. So the only thing new is the r. The r is the common ratio. Just like with arithmetic, we got a common difference. Common ratio is what you're multiplying by. So that's what the term is called. We're going to do sums of finite geometric sequences, and we're going to do sums of infinite geometric series. Okay, one thing I want to say about the finite. It has to be starting at 1. So if you have a problem that starts at 0, you're going to find the 0 one, and then you're going to use the formula for the rest, and then we're going to add the two answers together. This is your formula. Everything in here you should know. A1's first term, N is your terms, and then R is something new, which is your common ratio. Infinite. Infinite means goes on forever. In order to use this formula, R has to be between -1 and 1. So we're going to do the problems that are on board now that have nothing to do with the sum. Then we'll do problems that deal with both of those kinds of sums. Okay, kind of set up similarly to section 9.2. So the first part says determine if the sequence is geometric. If so, find the common ratio. Okay, so you're thinking, what are we multiplying by to get the next term? So if I look at number 1, well, to get from 3 to 12, I would multiply by 4. So get from here to here, I'd multiply by 4. Okay, so if I want to get to my next term, I would have to be multiplying by the same number. Well, 4 times 12 is 48, not 21. So this would be no. Okay, if I want to go number 2, I'll get from 1 to -1/2, I multiply by -1/2. So I want to see is that consistent. Well, to get to be a fourth, I had to multiply by -1/2. And to get to be -1/8, I had to multiply by -1/2. So this would be yes. And since that was the number, that's called our common ratio. So whatever we multiply by is called the common ratio. Okay, next part we're going to find the first 5 terms of the geometric sequence. Okay, I'm already given A1 and R. R is what you're multiplying by. So if I want to find the first 5 terms, I already know A1 is 2. So now I'm just going to multiply by 3. So if I want to find the second term, I would take 2 times 3, that gives me 6. And the next one, 6 times 3 is 18. And I would do 18 times 3, which is 54. 54 times 3, I think it's 162. Let me double check. Okay. So number 4, I'm getting my first term is 1. Then I'm multiplying by e. So it means A2 would be 1 times e, so that's e. A3, e times e, so that's e squared. A4, e squared times e, so that's e cubed. A5, e cubed times e, so that'd be e to the 4th. Okay, then number 5. So my first term is 3. Second term, we're going to take 3 times x over 5. So that'd be 3x over 5. Then I want to take 3x over 5 times x over 5. So that'd be 3x squared.